Welcome to physics class. Today we will discuss about the electromagnetic induction, the phenomena of generation of an electric current in a circuit from magnetic effects, that is by changing the magnetic flux linked with it, is called electromagnetic induction. Michael Faraday experimented with magnets and coils of wire until one day, in desperation, he threw the magnet down into the coil and observed that a momentary current was produced in the coil. Thus was made this very important discovery on 17th October 1831 after 6 years of hard labor. Faraday's experiment. The experimental arrangement used by Faraday consists of a coil C of a few turns of wire. A sensitive galvanometer G is included in series with the coil. When the magnet is stationary, there is no deflection in the galvanometer. Second, when the north pole of the magnet is brought towards the coil, a current flows in the coil. The galvanometer shows deflection toward right side. B diagram. If the motion of the magnet is stopped, the galvanometer again shows no deflection as in figure C. Thus, current in the coil flows as long as magnet is moving. Fourth, if the magnet is moved away from the coil, current flows in direction opposite to that in case B. And galvanometer shows deflection toward the left. This is regarding diagram D. Now, figure E, point 5. If instead of the north pole, the south pole of the magnet is either brought toward the coil or moved away from the coil, the direction of induced current in the two cases are opposite to that shown in B case. And D diagram. The directions of these currents are shown by full and dotted arrows, and the directions of deflection in the galvanometer are as in figure E. In case the magnet is moved faster, the deflection in the galvanometer increases. Exactly similar observations are made if the magnet is stationary and the coil is moved either towards or away from the magnet. The magnitude of the induced current depends on the rate of change of magnetic flux in the coil. The current produced in the coil by changing magnetic flux linked with it is called induced current, and the corresponding potential difference is called induced potential difference or induced electromotive force EMF. The phenomena is called electromagnetic induction. Faraday further found that induced EMF is possible even if there is no relative motion in case there are two coils. In the diagram, two coils are placed side by side, coil 1 and coil 2. Coil 1 is called primary coil and coil 2, in which current is induced, is called secondary coil. A battery, a key and galvanometer are also used in this circuit. When no current is flowing in coil 1, the galvanometer connected to coil 2 shows no deflection. The pointer of the galvanometer jumps to one side momentarily when key is inserted and current flows in coil 1. The galvanometer shows no deflection when current through the coil is constant. On disconnection from the battery, the galvanometer shows momentarily deflection but to the opposite side. A changing magnetic field in a coil induces EMF in another coil. It is possible by moving the coil in a magnetic field or changing the magnetic field in which coil is placed. The direction of induced EMF or induced current is given by Fleming's right hand rule. According to this rule, stretch the forefinger, middle finger and the thumb of right hand so that they are normal to one another. If the forefinger points in the direction of magnetic field, thumb in the direction of motion of the conductor, then the central finger or the middle finger will indicate the direction of the induced current. Here, the thumb represents the direction of motion of the conductor, first finger represents the direction of the magnetic field, and the second finger represents the direction of induced or generated current. Electric generator. An electric machine which converts mechanical energy into electrical energy is called generator. Principle: whenever in a closed circuit or coil the magnetic field line change, an induced current is produced. Construction: it consists of four parts: armature coil, field magnets, slip rings, and brushes or sliding contacts. For understanding its working, watch the next video. Thanks.